Hello everyone and welcome to another summer workshop series with Professor Thayer. Today we're going to be working with plotting with Python MatPlotLib. So let me just share my screen with you here and tell you a little bit about graphing with Python. Put up the slideshow here and setting. All right, so here we go. Today, as I mentioned, we'll be doing plotting with MatPlotLib. So just to give you an overview of what we're going to talk about today, we'll talk about line plots, we'll talk about how to customize your graphs, we'll also do histograms, and finally we'll round out the day with 3D graphs. So to start with line plots. So in order to plot our data, we're going to need some X and Y data. So we have a data set up here in order to give us some data that we're going to plot. This is an example of how you would start off doing your plot. So first of all, we would need to import NumPy and we would need to import PyLab, which is part of the MatPlotLib package. We would read in some data for X and also for Y. So this is just typing these into lists. The next thing we're going to do is we're going to use the plot command in order to generate the plot. It's important to understand that just because you give the plot command that the plot will not actually show, that the next step is required to actually display the plot. So the pl.show is what actually generates our plot. So this will pop up. How can we customize our graphs? So the next thing we might want to learn is how to customize the lines that are displayed. The colors, the line style, and the marker type are common things that you may wish to change. In order to change the color of the line in the plots, you're going to include in your pl.plot line this information over here. So there are in fact color codes. This single R in the quotes as a string means that the graph will be shown with a red trace as we see here. There are additional colors besides red. This is showing all of the standard colors that are available. So you should select the single letter here and put it into your plot command as was just shown. You can also change the line style. So similar to what we just saw for the colors, the line styles are also indicated by a single character tags that you're going to use in order to, well, most of them are single. There's a double right there. But most of them are single, and what you're going to do is you're going to use these in order to show how to plot your graph and how you would like it to be displayed. So for example, using the underscore will make a solid line. 3 is going to make a triangle pointing to the left kind of a marker, and so forth. How to specify the line type, marker, and color. So now that we've seen the table, now what we're going to do is talk about how you can actually display that. So you would use again your plot command, and what you would do is you would select the information that you want to put into your marker. The marker style can be changed using these specific tags. So square, pentagon, star, hexagon, another hexagon style, the actual plus marker, X, diamond, and thin diamond are the options that are available to you. We can also plot histograms. So this is a little script that will set up a histogram of random numbers. You may wish to use something like this to get a random number distribution to which you would compare some actual data. It could make a good null model. Here we're going to import NumPy and import PyLab as before. Then we have our comments here at the top of the script indicating that we're going to make an array of random numbers with a Gaussian distribution. The mean is going to be 5, and the RMS, which will control the root mean square, is going to control the width. That's going to be 3. And we're going to generate this with 100 data points. Here we see that we're using numpy.random.normal in order to do this, which is going to give our distribution up here. The 5 is the mean, The 3.0 is our width, and the 100 is the number of data points that is going to be generated. You can, of course, customize this to meet your own needs. Here we do plot.histogram of the data, which will plot this data. Here we're setting up a label, which is the frequency of number, and we see that that displays over here on the y-axis. Finally, we actually display the graph using the pl.show function. Next, we'll talk about the 3D graphs. So 3D plots, you need to import Axes 3D to provide the set of XYZ axes which is required for 3D plots. You'll also need to use MatPlotLib and NumPy. The next thing you'll do is define the figure, and then you'll define a plot in the figure. This is a little bit different than what we've done so far. And then, as before, the plot does not show immediately. You'll use the plt.show command in order to actually display it. So this is how we had set up a mesh plot. This is some code that we'll set up for a paraboloid. Okay, so in the beginning, what we're going to do is we are going to do our import. Here is the noted Axes 3D being imported from MPL toolkits. This is part of the MatPlotLib package which you downloaded. Here we're also going to download the PyPlot, also part of the MatPlotLib, and we're also going to import NumPy. Here we're defining a figure. Here is the axes, right? So figure adds subplot, and we're going to do a 3D projection to declare. So this basically is going to declare your 3D grid projections. The next thing we need to do is make the paraboloid. So we're going to get the coordinates for X and Y, and then what we're going to do is compute Z based on that. So here we are going to use numpy.range, right? So a range is going to generate the numbers over the -5 to +5 interval at 0.25. So they'll be 0.25 between each of them. And then we're also going to do the same for Y. And here's what we're going to do is we're going to establish the XY grid using the mesh grid, which is available through NumPy. And then the Z-axis is, we're going to use that to actually compute. So the way you're going to get a paraboloid is it's going to be a collection of parabolas. So we're going to do x squared minus y squared, where the x and y values are taken from these matrices we've set up above. And then if z is commented out, you'll get a flat graph. And then if you put z in, what that will do is that will allow for a particular grid to be shown. So you can experiment with commenting out, oops, this line or the next line here. So this, if you comment out this one and have z equals 0, that means your height will be 0, so you'll get a flat grid. And then if you turn back on this line right here, where we're actually computed the z dimension, then that is what will give you your paraboloid. So make the wireframe plot and render it. So what we're doing is AX plot wireframe XYZ. This is the syntax for the wireframe type of a plot. And then, as we mentioned before, you need to, in fact, actually show your plot. So here is our plot.show command, which displays the plot. And when we do this, we get out a graph like this, a three-dimensional mesh grid, which shows the paraboloid. All right, so we had a brief introduction to graphing in Python today. We talked about line plots, we talked about customization of graphs, plotting with histogram, and 3D graphs. I hope you found this introduction to be useful. I would like to invite you to join us for the tutorial which accompanies today's talk. Please fill that out and work through those exercises to gain some hands-on experience working with graphs. All right, thanks very much, guys. Bye-bye.